Hello, today we will start with chapter 5. This is about cardiopulmonary bypass. Cardiopulmonary bypass machine is often or is also referred to as a heart-lung machine or the pump. It's a pump. Uh, so this is called the cardiopulmonary bypass or heart-lung machine. The primary function of cardiopulmonary bypass is to divert blood away from the heart and lungs and return it to the systemic arterial system, thereby allowing cardiac surgery. This is the primary function. So it's a technique that takes over the function of the heart and lungs. It takes over the function of the heart and lungs during a surgery. It allows to maintain the circulation of blood and oxygen through the body. فإذا هذه الماشين cardiac pulmonary bypass or what's called heart lung machine بنستعملها عادة during surgery خصوصا open heart surgeries. هي بتحل محل الفانكشن. It replaces the function of the heart and lungs during surgery. طبعا هذه الماشين is operated by perfusionists. The perfusionist who is specialized healthcare professional who use the heart-lung machine during the cardiac surgery. This machine is commonly used in heart surgery طبعا because of the difficulty of operating on the beating heart. And it's difficult to do the open heart surgery while the heart is beating. The surgeons must stop the heart working and beating. Then they work to replace a valve, to open arteries, and so on. So operations require the opening, some operations during open heart surgery require the opening of the chambers of the heart. And so we need a cardiopulmonary bypass to support the circulation during this period of operation. So this machine nourishes the blood cells and allows them to continue cellular respiration even through surgery. Also, this cardiopulmonary bypass can be used for the induction of total body hypothermia. When I say hypothermia, it's a dangerously low body temperature. So hypothermia occurs as your body temperature falls below 35 degrees. So this machine is used for the induction of total body hypothermia, a state in which the body can be maintained for up to 45 minutes without blood flow. This is also applicable and useful during open heart surgeries. Because if the blood flow is stopped at normal body temperature, permanent brain damage may occur in 3 to 4 minutes, and this is followed by death. So this is dangerous. We cannot stop the blood flow at normal body temperature. فإذا الجراح عادة بخلال عملية القلب المفتوح بيشتغل لحتى يخفض حرارة الجسم، وهيدا بنسميه هايبوثيرميا، لحتى تصير حرارة الجسم أقل من 35 درجة. فإذا at low body temperature the blood flow could be stopped. فإذا ال CPB or cardiopulmonary bypass can be used to rewarm individuals suffering from hypothermia. This surgical procedures in which cardiopulmonary bypass is used are the following. This machine could be used in coronary artery bypass surgery, cardiac valve repair or replacement, heart transplantation, and pulmonary thrombectomy. Thrombectomy means when we remove blood clots from the pulmonary arteries. So during these surgeries or during these surgical procedure, a surgeon must use the cardiopulmonary bypass machine. How this machine works, we will see this in details. Look at this figure. In this machine, the blood is gravity drained from the heart to a reservoir. So look, via these venous tubing, we have here the venous tube. The blood is gravity drained from the heart to a reservoir. The reservoir is called venous reservoir. So the blood is gravity drained from the heart and returned oxygenated to the aorta. Look here at this red arrow. So the blood is returned to the patient via the aorta using a pump. The tubes are manufactured of polyvinyl chloride, PVC. This is the material. This is a polymer, one kind of polymers, polyvinyl chloride. So the tubes are made of polyvinyl chlorides because it's biocompatible. It's blood biocompatible. Look at this figure. So according to this figure, look, we have the blood is gravity drained from the venous via venous tubing. So here, blood is gravity drained from this location or from this location and to a venous reservoir. So this is the venous reservoir, Also, you can look at this figure. These are the tubes. This is one tube, and this is another tube. So the blood is drained from via these tubes, and it's returned to the patient via the aorta. So from this side, via this tube. Here, a cross clamp is placed. Look, a cross clamp, مثل ملقط. It's called the aortic cross clamp. It's placed across the ascending aorta to prevent blood entering the chambers of the heart. Okay. This is the principle of the machine. This is a complete block diagram of the system. فإذا this is a simplified circuit diagram. The cardiopulmonary bypass is looked like an open circuit in which the venous blood drains into the venous reservoir by gravity. يعني هون تقريبا between 40 to 70 centimeter. This reservoir is located below the level of the heart, تقريبا between 40 and 70 centimeter. This is why I say that the blood drains by gravity. Okay. So blood flows by gravity from the right atrium into or through a cannula into a venous reservoir. It's then pumped through a heat exchanger and oxygenator or gas exchanger, and then through an arterial filter or what's called an arterial microfilter, and is returned to the systemic arterial system or what's called the ascending aorta. So this is the circulation, how the circulation is done. Also blood from cardiotomy reservoir, blood transfusions or other fluids may be added into the circuit. And the blood passes through the oxygenator and through a heat exchanger and is returned to the arterial system by utilizing a roller or a pump. Also, we have here an arterial filter. We will see, we will discuss in details each of the components of the cardiopulmonary bypass system. So during the cardiac surgery, it's necessary to aspirate blood from the cardiac chambers to provide adequate exposure of the surgical field. This is why we use also a cardiotomy reservoir. This is the cardiotomy reservoir. So here we have a suction device to aspirate blood from the cardiac chambers during the surgery. And the recycling of suctioned blood from the surgical field is accomplished by this cardiotomy reservoir. This cardiotomy reservoir includes also an air fluid separation chamber, a chamber that separates air from fluid. It includes a temporary storage reservoir for priming solutions. When I say priming solutions, هلا ال priming solutions are mixture of crystalloids and colloids. This priming causes what's called the hemodilution, which improves flows during hypothermia. فإذا it's composed الcardiotomy reservoir include an air fluid separation chamber, a temporary storage reservoir for priming solutions, filtration of particulate materials like clots or blood cell aggregates. Also, the cardiotomy reservoir is used for the addition of fluids and other agents to the perfusion circuit. These are the functions of the cardiotomy reservoir. This is the cardiotomy reservoir. Now, the venous reservoir, this venous reservoir, it's like a capacitance chamber. It acts like a capacitor. The filtered venous blood is then drawn from the reservoir and pumped toward the heat exchanger and oxygenator. We have two types also of arterial pumps that can be used. These types are the peristaltic roller pump and centrifugal pump. So here, when the blood comes back to the heart via the aorta, here we need a pump. We have two types of pumps that can be used. The first pump is called peristaltic roller pump, and the other type is centrifugal pump. The peristaltic pump is like this. So this figure illustrates an example of peristaltic pumps. Look, it includes the rotor. The rotor has a number of rollers, 1, 2, 3, attached to it. Here the tube is compressed at this location. What happens here is that as the rotor turns, the part of tube under compression, so this part, forces the fluid to be pumped to move through the tube. And as the tube opens, also fluid flow is induced to the pump. So this is how the peristaltic pump works. So it's composed of a rotor. As the rotor turns, it forces the fluid to be pumped and to move through the tube. The other type of pumps is the centrifugal pump. This is a centrifugal pump. It's composed of an impeller eye. This is the impeller eye. So the fluid is directed to the impeller eye, or like seen in this figure, fluid into the impeller eye, and is forced through a circular movement by the rotation of the impeller veins. So here we have veins. The impeller veins, while rotate, it allows a circular movement that forces the fluid to go out of the pump. So these impeller veins transfer mechanical work from a motor to the fluid in the impeller channel. So the fluid, I can say that the fluid is pressed out of the impeller, so fluid out here at this location, by means of a centrifugal force. And the fluid leaves with increased pressure and velocity. Centrifugal force can be defined by this formula. So centrifugal force is equal to the mass of the blood times the radius of pump head times the speed of revolutions, RPM. So if we multiply these parameters, we obtain how much is the centrifugal force. Also, one can calculate the blood flow rate. It depends on the pressure gradient, the tube radius, fluid viscosity, and tube length. So blood flow rate is given by this formula. This is the Poiseuille equation.